Okay, this lesson is 5.4. So we're going to be focusing on solving special systems of linear equations. So just to recap, so far in this chapter we have learned what a system of equations is. And remember, that's whenever you have at least two equations. And you're trying to figure out where those two equations would intersect, or if we're talking about money within the problems, what that break even point would be. So first of all, we looked at graphs. We graphed both equations, and wherever they intersected was your solution. And then we looked at substitution. We took, for example, what y equaled, plugged it into the other equation, and solved it. And then most recently, we looked at solving them by elimination, where you wanted one set of variables to cancel out. Either the x's cancel out or the y's cancel out. So what we're going to look at today are special, unique situations where really you could tell what's going to happen just by looking at the equation. You won't need to actually do anything about it unless they actually want you to solve it. So we are on page 113 in your workbook. It should be 5.4 at the top. Okay, and let's look at activity 1. It says your cousin is 3 years older than you. Your ages can be represented by two linear equations. So your age is y equals t. So t would be however old you are. And then your cousin's age would be y equals t plus 3. So your age plus 3 because he's 3 years older than you. Now, part A says graph both equations on the same coordinate plane. So we have a graph over here to the right. And we're going to simply graph both of those. Now, remember, whenever you have an equation solved for y, it makes it really easy to graph. Y equals mx plus b. Now, in these two equations, the t is in place of the x. So just keep that in mind. So in this first equation, if I go to graph it, remember you want to plot the y-intercept first. And that is the number that's in the b position. Now if you look at this equation, there's nothing in the b position. It doesn't say plus anything or minus anything. So your y-intercept for this equation is going to be 0. Okay, so I'm going to plot 0. Then your slope, this is what you're going to do second. Use your slope. And remember, slope is rise over run. Okay, so your slope is the m value. What's in front of the x? Or in this case, what number is directly in front of the t? Well, there's nothing there. So we know that technically that is a 1. And if we write 1 as a fraction, it's 1 over 1. So that means I'm going to rise 1 and run 1. So from my point, rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And you can keep doing that over and over again. But then go ahead and draw your line through there. Try to make that as straight as possible. Okay, and then we're going to graph your cousin's age. So again, looking at this form, plot the y-intercept first. So what number is in the b position? That would be 3. So I'm going to come up and I'm going to plot 3 first. And then the slope, the number in front of the t, well, that is again 1, which is 1 over 1. So I'm going to rise 1, run 1. Rise 1, run 1. And I could keep doing that. And again, I'm going to connect these and try to keep it as straight as possible. And just like that. Now, if you notice, one thing I want you to make note of with each of these equations is that they both had a slope of 1. And that we'll look at that more in depth a little bit later, but keep that in mind as we go through this. So now that we have them graphed, let's look at part B. What is the vertical distance between the two graphs? So if I take two of the points, let's say I take this point and this point, what is the vertical distance? How far is it from here to here? 1, 2, 3. Okay, so the distance is 3. And what does that distance represent? Well, that was the age difference between you and your cousin. Okay. Part C says, do the two graphs intersect? Okay, so if you look at your two lines, do they intersect? Will they ever intersect? No, they will not, because they are two parallel lines. And then it says, explain what this means in terms of your age and your cousin's age. Well, if those two graphs were to intersect, think about what that would mean. Okay, if this green line is your cousin and this red line is you, if those lines were to intersect, that means that at some point you and your cousin would be the same age. And you guys know that's not true. If he's 3 years older than you, there is no point where you will be the same age. So, what does this mean in terms of your ages? You will never be the same age. Okay? Now, moving on to activity 2. Scroll down a little bit. We got a different sort of problem, but we're going to solve it a little bit different way. Instead of graphing it, we're going to make a table, first of all. So it says you invest $500 for equipment to make dog backpacks. Each backpack costs you $15 for materials. You sell each backpack for $15. So we've kind of talked about in this chapter cost versus revenue, and that revenue is the amount that you are making off of this. So before I start filling in the table, I need to set up an equation for the cost and the revenue, and then I can fill in the table. So let's think about the cost. Okay, you have an initial $500 that you're spending for the equipment, and then every backpack you make costs you $15 to make it, just in the materials. So to write my equation, I'll just put it right out here to the side. We have the cost is 15x, because it's $15 per backpack, plus the initial $500 that you spent for the equipment. Now, we'll do the revenue here in just a minute, but let's go ahead and fill out the row for the cost. So they give me all of my x values right up here. So if x is 0, so that means I take 0 and I'm going to put it right in where the x is, and then I'm going to solve it. So 15 times 0 is 0, plus 500 is 500. Then I'm going to plug in a 1. 15 times 1 is 15, plus 500 is 515. Now I'm going to plug in a 2. 15 times 2 is 30, plus 500 is 530. And I notice a pattern going on. Notice it's going up by 15 every time. It's going to keep doing that because it's $15 per backpack. So I'm just going to continue filling this out. And I end up at $650 when X is 10. So that means if you make 10 backpacks, you have spent a total of $650. Now, the R is the revenue. How much are you making off of each backpack? Well, it told us you sell each backpack for $15. So the revenue is going to be $15 times X. So 15 times however many backpacks that you sell. So again, I'll just take each one of these numbers and plug it in for X. So if X is 0, 15 times 0 is 0. 15 times 1 is 15. 15 times 2 is 30. And again, it's going up by 15s. So I'll go ahead and fill this out. That's 150. Okay, so now we got a few questions to answer over on the next page, page 114. So B says, when will you break even? So if you look back at that table, is there a point that you notice where the cost and the revenue are the same? And if you look through that table, nowhere in there are they ever the same. So when will you break even? Never. And what's wrong with that picture? Well, if you noticed, you may have noticed this right in the beginning when we read the problem, that it cost you $15 to make a backpack, and you're only selling it for $15. So you can't expect to make a profit if you are selling the backpack for the same price that it costs to make it. So we'll say you can't make a profit if you sell the backpack for the same price, or the same cost, I guess, it is to make it. Okay, so you will never break even. You're going to have to start selling it for more in order for you to start making money off of it. Now I've jumped back up to activity 2, but one thing I want you to notice if you look at both equations is, again, they both have the same slope, the same number in front of your x. So there will never ever be a point where they're going to intersect, or ever a point that you're going to break even. So keeping that in mind, I want to skip all the way down to page 115 on what is your answer number 4. It says, can a system of linear equations have no solution? That's what we have been talking about. So no solution, that's my abbreviation for no solution. What's going to happen is you are going to have parallel lines. They will never intersect. And what you're looking for in your equations is if they have the same slope. You don't even have to graph them. If they have the same number in front of the x, they're going to be parallel, no solution. Can a system have many solutions? This will only happen if they are the exact same line and the exact same equation. Exact same line, exact same equation. Okay? And then there's one other thing we'll have, and that's one solution. And that's what we've done the entire time up until now. Your graphs will intersect at one point. And sorry, that was my phone that just went off. Okay, so really any system can have one of 3 answers. It can have no solution if they're parallel lines. It can have many solutions if it's the same line, and one solution if those 2 lines intersect at only one point. Okay, so now what you're going to do is you're going to flip over to the next page, page 116, and you are going to complete these 5 problems. Basically answering, is there one solution, no solution, or many solutions?